Hello everyone, welcome to this video. Let's start with the solution of LTC AIIMS Chemistry Weekend Test number 16. Question number 1. Of course, this is Rosenmund reduction because in this reaction an acid chloride is reduced to aldehyde in presence of a poisoned catalyst. The reducing agent used in Stevens reaction, of course, SnCl2 plus HCl. In Stevens reduction, nitriles are reduced to esters via the formation of imine intermediate, right? Aldehyde is being converted to an alkane. In this reaction, X cannot be, of course, lithium aluminum hydride because it reduces aldehydes to primary alcohol. The product X in this reaction is, of course, benzaldehyde because it is etard reaction, in which toluene reacts with chromyl chloride followed by hydrolysis to give you aldehyde. CH3MgI HCN. In this case, there is a nucleophilic attack of Grignard reagent, right? So this is reaction is like this. Right, and when then this intermediate undergoes hydrolysis, it produces acetaldehyde. So the product is analdehyde. Two molecules of acetaldehyde in dilute NaOH followed by heating. Of course, it is aldol condensation reaction in which the product is. So what happens, guys? First, the step is the formation of enolate ion, which attacks the nucleophile. So this is CH2 minus CHO. Then it attacks another molecule of acetaldehyde. Then we get this CH3 CHO minus and then CH2 CHO, right? Then it takes up a proton from the solvent and gives you aldol addition product. All right. And because the dehydration product is resonance stabilized, the application of high temperature results in the formation of crotonaldehyde, alpha beta unsaturated aldehyde. CH3 CH double bond CH CHO, right? This is crotonaldehyde. Which one of the following compounds has the highest boiling point? Of course, propanol because of the hydrogen bonding, which is absent in all other three compounds. Among the given compounds, the most reactive compound toward nucleophilic addition is formaldehyde. Remember, aldehydes are more reactive than ketones towards nucleophilic addition reaction because ketones have two electron donating bulky alkyl groups, but aldehydes have only one. Which one of the following compounds cannot undergo Cannizzaro reaction? Those which have an alpha hydrogen, they do not undergo Cannizzaro reaction in alkaline medium. Instead, they undergo aldol reaction, right? This one, and this one, they don't have alpha hydrogen, they will undergo Cannizzaro, but this will not. The compound hemiacetal is an alkoxy alcohol. So, for example, this is an aldehyde, right? The product that forms after the addition of first equivalent of alcohol, which would be this one, RCH, this would convert to OH and this would convert to OR. So this is alkoxy alcohol, this is a hemiacetal, right? When two equivalents of alcohols add to an aldehyde or ketone, it gives you complete acetal, right? Acetamide is a functional isomer of acetaldoxine. Yes, correct. Acetamide is this CH3CONH2 and acetaldoxine is CH3 CH double bond NOH, the product of the reaction between hydroxylamine and acetaldehyde, right? So this is correct. Rochelle salt is sodium potassium tartrate. So this is incorrect and hence it is a correct answer. Aldehydes form Schiff's base when they react with primary amines. Okay. The starting material in Gatterman-Koch reaction to prepare benzene carbaldehyde, that is benzaldehyde, is of course benzene, CO and HCl. In this reaction, they react in situ and they form HCOCl, which then generates the electrophile, and then we get benzene carbaldehyde. So this is the correct answer. Which one of the following hydride has the least pK value? Of course, this is H2T because down the group, bond strength decreases and as a result, acidic strength increases, right? Because acidic strength is inversely proportional to pK value. So H2T is most acidic. These are group 16 compounds. The correct order of melting points of their hydrides. The element J in the sequence is selenium, of course, right? Because water has the highest melting point because of hydrogen bonding, and then tellurium, and then selenium, and then sulfur, like that. Okay. Which of the following statements of oxide of group 16 is incorrect? SO3 is anhydride of sulfuric acid, not sulfurous acid, right? So this one is incorrect. Rest of all that correct. Which of the following molecule has band shape OF2? Of course, right? SF6 is octahedral molecule, SF4 is a seesaw, and O2F2 it has H2O2 like structure. Reactions of oxygen are mostly exothermic in spite of a double bond in the molecule of oxygen. It is considered as a reactive element. Oxygen cannot react with noble gases and some of the noble metals directly. So gold is the most likely the correct answer here. Okay. At 1000 Kelvin, sulfur mainly exists in the form of S2 where it is paramagnetic because of two unpaired electrons just like oxygen gas. Incorrect statement among the following is monoclinic sulfur is insoluble in CS2. No, it is soluble in CS2, right? Formation of Carus acid, guys, it is H2SO5 which has a peroxide linkage, right? So this is Carus acid. Then oxoacid of sulfur which contain SOS bond is H2S2, which we also call peroxide disulfuric acid or Marshall's acid. So this I'm drawing the structure. This is the molecule. All right. Then chemical formula of fluorospar is calcium fluoride. This is cryolite. The halogen having the least magnitude of bond association enthalpy is iodine. The order is chlorine, right? Then bromine, then fluorine, and then iodine. Because of the lone pair propulsion, the FF bond in fluorine is very weak. The halogen with least melting point is of course fluorine. Down the group, molecular mass increases, and so the van der Waals increases forces, and the melting point increases, right? Fluorine is lightest, so it has the least melting point. The element Y in the sequence is chlorine because the oxidizing strength it increases. It decreases down the group. Fluorine is the most powerful oxidizing agent, followed by chlorine, then bromine, and then iodine. So Y2 is Cl2, right? Which one of the following hydride is thermally most stable? HF because of the strongest bond. All of the following are favorable condition. High charge of the cation, no. If the cation, high charge of the anion, no. Because if the anion has high charge, its size will be very huge, and then it will be easily polarizable, leading to covalent character. So this is not the favorable factor, hence the correct answer. Which one of the following molecule violates octet rule? Of course, because it has 5 covalent bonds, that is 10 electrons, right? All the species have regular geometry except ClF3. ClF3 has bent T shape. Because of the lone pair bond pair repulsion, these bonds they bend, and the bond angles are less than 90 degree with the equatorial groups, right? So this is the correct answer. The species with maximum bond angle among the following is BCl2 180 degree sp hybridization. The bond angle in ammonia is approximately 107 degree. SO3 it's 120 degree. H2 is approximately 90 degree. Hybridization of central element XCF2 molecule is sp3d, right? Because it's xenon. The three lone pairs they are located on the equatorial position, and the two fluorines are on axial position. Is that clear? So linear shape, trigonal bipyramidal geometry is sp3d hybridization. Which one of the following species is diamagnetic with the bond order of 2? Of course, C2. In B2, bond order is 0, and 2, the bond order is 3. B2, bond order is 1. Okay, so that is only the correct answer. Intermolecular hydrogen bonding leads to association which cannot involve an intermolecular hydrogen. HCl does not show hydrogen bonding. Amines, alcohols, and water they do. CO bond in carbonate ion you guys can find out, right? Because of resonance, the bond order is averaged out. Total number of bonds is 4, and the bond positions are 3. So the average bond order is 4 by 3, which is 1.33. Which one of the following compounds give characteristic color with 2,4-DNP reagent, which we also call Brady's reagent? Remember, aldehydes and ketones react with 2,4-DNP reagent to give orange, yellow, or red colored solid. So all the statements are correct because aldehyde, ketone, ketone, and ketone. And acetaldehyde and benzaldehyde can be distinguished by Felling's reagent because Felling's reagent does not oxidize aromatic aldehydes, right? So benzaldehyde will not react in Felling's test. Yellow crystals of CHI3 it's given by methyl ketones, guys, or acetaldehyde also gives this test because it also has this functionality, And then all alcohols, secondary alcohols like this, okay, they also respond to iodoform test. But this is an aldehyde. The only aldehyde that gives iodoform test is acetaldehyde, right? So of course this will be the correct answer. This won't give yellow crystals of Sri Chaitanya. This is the preparation of ketones, C2H5 MgCl Grignard reagent. On reaction with cadmium chloride, it forms diethyl cadmium, C2H5 twice Cd, and then it reacts with acetyl. This is propanoyl chloride, and then it would be C2H5 carbonyl group. Chloride is a very good leaving group. It will be replaced by this. So we'll get pentane. This is the correct answer. Acetaldehyde is this, right? When it reacts with HCN, then cyanohydrin is formed. This is a product, CH2CHOHCN. And when this undergoes hydrolysis, of course, cyanide is converted to uh, carboxylic acid, right? So this is the smallest alpha hydroxy acid. This one is this. Uh, this is lactic acid. Remember this, right? The IUPAC name of benzyl acetophenone, you can write the name from here, 1, 2, 3, right? So 1,3 diphenyl prop 2 1 O. So this is the correct answer. The functional group not present in the organic compound vanillin is, of course, this ketone group is not present. Alcohol, that is phenol, is present. Alkoxy, that is ether, is present, and aldehyde is present. In the formation of ozone from oxygen, so it is 3 oxygen gives 2 OH3, O2, right? Yeah. So in the formation of ozone from oxygen by silent electric discharge, the correct signs of enthalpy, entropy, and Gibbs energy change. So of course this would be because ozone is less stable. So this reaction is endothermic. Because 3 particles are getting converted to 2 particles, so number of particles decreases, entropy decreases, and because ozone is less stable, this reaction is not spontaneous. Gibbs energy is positive, right? So this would be the correct answer. Bond angle in ozone is approximately 117 degree. Hybridization of the central oxygen is sp2, so of course near 120 degrees. Sulfur dioxide behaves like carbon dioxide in its reaction with NaOH, right? Because KMnO4, ferric, potassium dichromate, these are oxidizing agents. They cannot oxidize CO2, they oxidize SO2, right? But NaOH is a base, both SO2 and CO2, they react similarly. So this is the correct answer. The following acid cannot be prepared from its salt using sulfuric acid HI, because when you try to react HI with sulfuric acid, now remember sulfuric acid is a moderately strong oxidizing agent. It oxidizes iodide into iodine. So if you want to prepare in situ HI, you react with H3PO4 with any salt of iodide, right? So H3PO4 that will generate HI in situ. Contact process, the commercial method of manufacturing H2SO4. The principal step is of course this catalytic oxidation of SO2 to SO3. Which of the following is used in bleaching? Again, factual. CaO2 is used in bleaching water and paper pulp. Which of the following is a known polar molecule? You can find out the dipole moment. SO2 does have dipole moment because it is an unsymmetrical molecule. PF3 has regular geometry. Bond dipoles are cancelled out, leading to zero overall dipole moment. SF4, you can find out the shape, right? It has dipole moment. Water, of course, it is a highly polar molecule, so the only correct answer is BF3. Among the following species, O bond order is highest. And remember, guys, then O2 2 plus. This order you should remember. It will be very beneficial. O2 plus, and then O2, and then O2 minus, and then O2 2 minus. The bond order in these species is 3, 2.5 to 1.51. So the correct answer is here O2 plus. All right, guys. Thank you.